All right, boys and girls, this is homework. It's a little bit late, but you guys are going to have 3 days to do it. Also, Mr. Orange here wants to tell you guys tomorrow's report card pickup. So obviously you don't have school, so show up to the building and pick up your packets. Otherwise, something happens. But yeah, seriously, in order for you to be really effective at this math stuff, show up. Show up to the building, pick up the packet. It's going to be open from 7 to, I don't know when, 5 or something. So you have all day, show up, okay? Let's take a look at this very quickly. This lesson is super easy. It's actually the same lesson that you guys did on Thursday or today. It's backwards, okay? So basically now they're going to want you to make other proofs, but the proofs is just the same thing. It says angle 1 is congruent to angle 8, okay? If this is true, and they're telling you that it's true, right, because it's given, if this is true, what is the next conclusion that you can make? What are these angles anyway? The alternate exterior. Well, if this is true, that basically means that P and Q are parallel lines, okay? So you're right, line P is parallel, right, parallel to line Q, right? How do you know that? Because if, well, you can say if alternate exterior angles are congruent, and this is what we did today. If alternate exterior angles are congruent, then P and Q are parallel, right? Then the two lines are parallel. The two lines are parallel. All right. So how's this different? Well, now that you have this idea, you're able to make one more conclusion. And actually from this idea, you're able to conclude then that angle 3, right, is congruent to angle 6. Why is that? Well, look at what 3 is and look at what 6 is, right? And so the next conclusion is if two lines are parallel, if you have two lines that are parallel, right, then you have the alternate interior angles have to be congruent. And that's it. This is literally the same proof, but now it's backwards, right? So if alternate interior angles are congruent, then you have two parallel lines. And if you have two parallel lines, then you're able to prove other angles, which means you're able to prove alternate interior angles as well. Okay? That's literally the same things. These questions below are going to be reviewed. I'm tempted to do one more over here, but it's same idea, right? Let me get this started for you. So the first thing that's given to you, right, is that 4 plus 5 is equal to 180. Okay, so let's take a look at this. 4 is right here, and 5 is right here, okay? They're equal to 180. Okay, if this is equal to 180, what's the logical conclusion that you can make about lines in general? First off, these are same side interior. And you guys remember same side interior can only exist if something happens, right? This can only exist if these two lines are what? Right? So you write if, you know, if same side interior angles are supplementary, in which they are, right? Then the conclusion is that line AB has to be parallel to line CD, okay? And because they are, then you say two lines are parallel. And when they are parallel, what ends up happening is that you're able to finally prove the third proof, which is that angle 3 is going to be congruent to angle 7, and that's up to you to explain why it's congruent to angle 7, okay? How does this detail help you make this conclusion?